Hello everyone, back to our channel Apna Tutors. So in this video we are going to do the chapter 1 exercise 1.1 question 2 and question 3. Okay, so let's start our video. So what is second question? So that the relation R in the set of real numbers defined as having pair a comma b such that a is less than equals to b square is neither reflexive nor symmetric nor transitive. Okay, so first of all let's show that it is not reflexive. So for that what we need to do, we need to find one element a from R such that a comma a is not in R. But what does this mean? It means that a is, if a comma a is in R, then a is less than equals to a square. But we are having a comma a is not in R. That will means a is not then less than equals to a square. So what you tell me, what type of elements should we pick so that we'll get that its square it's not less than equals to. Okay, so if you will be taking a greater than 1, then of course its square will be greater than its term, right? So of course we should pick element less than 1, then our work will be done. So suppose I pick a equals to 0.5, then 0.5 is not less than equals to 0.5 square is 0.25, right? So this element will gives us that we had found one element a for which a comma a is not in R, which gives R is not reflexive. Now let's do that R is not symmetric. How will do R is not symmetric? What does symmetric gives? That if AB is in R, then we should have BA in R. So we should find one AB in R such that BA is not in R. It's easy, right? So we need to find AB in R. That is A is less than equals to B square. But BA does not belongs to R. That is B is not its less than equals to A square. So we need to find element like this. So suppose I take element as let me pick 2, 3. Let's see whether it works or not. I also don't know that whether it will work or not. So if we pick 2, 3, then of course 2 is less than equals to 3 square, that is 9. But let's see whether 3 comma 2 belongs to R or what not. So for that we should have that 3 should be less than equals to 4. Yeah, so here it is holding, right? So this element will not work. I am just showing how to think of these such elements. Okay, so this element will not work. So we should pick in such a way that a is less than equals to b square, but b is not is less than equals to a square. So I need to pick elements such that b does not get less than equals to a square. So let's keep this b as fixed, right? That we are having b as fixed, that we are keeping b as 3. In what way should we pick a such that a is less than equals to b, but b is not less than equals to a square? So you can see in place of 2, if I pick 1, then of course 1 is less than equals to 9. But whether 3 is less than equals to 1, because 1 square is 1. Why I picked 1? Because I know that 1 square is 1, which that means square will not affect much. That's why I had picked 1. So you can clearly see 3 is not less than equals to 1, which implies 3 comma 1 does not belongs to R. which implies R is not symmetric. Okay, done with this symmetric. Now let's move to transitivity. Okay, so for transitivity, what you want, that A is less than equals to B square. A is less than equals to B square. B is, let me show in detail only, that A comma B is in R. B comma C is in R. But A comma C is not in R. This is what not transitivity will mean, right? Because transitivity will mean that A comma C will be in R, but not transitivity will be in, means that we will be able to find such A comma B and B comma C from R such that A comma C is in not in R. So let's try to find such element. Okay, so let's again do by that again normal process. If I pick suppose A comma B as 2 comma 3, then will it be in R? Yes. Why? Because 2 is less than equals to 9. And if I pick, now I should be careful while picking C, right? Because I will have to pick C such that A and C are not related. That means 2 should not be less than equals to C square. Okay, first of all, in place of 2, I should pick 5, that is number bigger than 3. The reason of this I will tell you in shortly. Whether this will hold, because 5 is less than equals to 3 square 9. Now I should pick the next element in such a way, that is 3 comma C. C should be picked in such a way that 5 is greater than C square. Then what should be the ideal choice? I think if I pick 2, whether 3 comma 2 will be in R? Yes, because 3 is less than equals to 2 square 4. Now you see whether 5 comma 2 is in R or not. It will not be in R. Why? Because what will be 5? 5 will not be less than equals to 2 square 4. Now did you got the reason why I had chosen the element bigger than 3? If I had chosen element less than 3, then its square would obviously had been less than 4, right? That's why I had tried to pick element greater than 3 so that it will work. So finally we are having one element which 5 comma 3 is in R, 3 comma 2 is in R, but 5 comma 2 is not in R. So this shows that it is not, R is not transitive, right? So we got the answer of question 2. We had shown it is not reflexive, not symmetric, and not transitive. So let's move to next question. So what is question 3? Check whether relation defined in the set 1, 2, 3, 4, 5, 6 having element, and R is defined as having pair A comma B such that B is equals to A plus 1 is reflexive, symmetric, or transitive. We have to check whether it is reflexive, symmetric, or transitive. The similar question we did in question 1, right? But now I will try to do it in little bit different way. Okay, so let's check whether first it is reflexive or not. Reflexive, question mark. Okay, so if it is reflexive, what should I have for every A in this set? Let me name this as A. That is, for every A belongs to capital A, small a belongs to capital A, I should have A comma A in R. But how R is defined? Having element B equals to A plus 1. So I will get A is equals to A plus 1. But this will imply cancelling A from both sides will imply 0 equals to 1. But this is not true, right? This is called contradiction. Right? by assuming something wrong, we got something wrong, right? So this shows that our assumption was false. That is, for you can't have that for every a belongs to a, you will not have a comma a in R. This shows that our R is not reflexive, because if R is reflexive, then we are getting the 0 equals to 1, which is not true. So R is not reflexive. So now let's do for symmetric. Let me clear erasing this part. B is symmetric, right? For symmetric, what you should have, that for every a comma b in R, we should have b comma a in R, and we need to check this whether this hold or not. Suppose it holds, that the way which we did in for reflexive. Suppose it holds. If AB belongs to R, what does this mean? That B is equals to A plus 1, and BA belongs to R. What does this mean? A is equals to B plus 1. So if I put A equals to B plus 1 in this equation here, what I will get? B equals to B plus 1 plus 1. Again I will get 0 equals to 2, which is false. So again, the way we did earlier, the relation R is not symmetric. Now let's move to transitive part. Transitive part C. So for transitive, if I pick any element AB and BC in R, if I am getting AC in R, then R is called transitive. So let's do by same process. Suppose AB and BC is in R, that is B equals to A plus 1 and C equals to B plus 1, and AC, if I am getting AC in R, then what I will get is C equals to A plus 1. So if I put from here, what I will get, B equals to C minus 1. So putting that in this equation, that is in place of B I put C minus 1, I will get C minus 1 equals to A plus 1. This will imply C equals to A plus 2, but here I was having C equals to A plus 1, here I am having C equals to A plus 1, A plus 2. So if I put C equals to A plus 2 here, what I will get? A plus 2 equals to A plus 1, which will imply 2 equals to 1, which is false. Thus our relation R is not transitive. So thank you for watching this video. We will meet in next class with next number of question. Okay, thank you. So please subscribe our channel Apna Tutors.